Finding the greatest common factor. The greatest common factor is the largest number that's a factor of two or more numbers. So for example, if I think about 6 and 8, the greatest common factor is 2. And the reason it's 2 is because 2 is the greatest number that will divide evenly into 6, that will also divide evenly into 8. Okay, so it's the greatest common number that goes into both 6 and 8. There are several ways to find the greatest common factor between two numbers. I'm going to show you several different ways. Now, what I want you to do is as you listen, I want you to listen to all three methods that I show you. And I'm going to suggest a method that I think is best, but I want you to listen and see what seems to make the most sense to you. Okay, so one way is simply to make lists. Okay, the first way I'm going to show you is just making lists. Okay, so let's list all the factors of 12. And remember, factors means something that goes into another number. So factors of 12 are numbers that divide evenly into 12. So 1 goes into 12. Now, 1 goes into 12 how many times? 12 times. So 12 is also a factor of 12. 2 goes into 12. 2 goes into 12 6 times. 3 goes into 12 4 times. Okay, so the factors of 12 are 1, 2, 3, 4, 6, and 12. Now let's make the list for 24. 1 goes into 24 24 times. 2 goes into 24 12 times. 3 goes into 24 8 times. 4 goes into 24 6 times. 5 doesn't go into 24. 6 goes into 24, and that's in our list, so we know we're finished. Now, after I list the numbers, I circle my common factors. So both lists have a 1, both lists have a 2, both lists have a 3, both lists have a 4, both lists have a 6, and both lists have a 12. Those are their common factors. 1, 2, 3, 4, 6, and 12. The greatest common factor is the largest number. So what is the greatest common factor? 12. That's one method to find the greatest common factor. I do not think this one's the most effective because it takes a while to make the list. But maybe you may prefer this one. Let's go on and look at another method. Another method to find greatest common factor is to make factor trees, okay? So remember, factor trees, we did that in the last two lessons. Let's make a factor tree for 12. 3 times 4 is 12. 3 is prime, so I'm done with that branch of the tree. 4 is not prime, so I got to keep going. 2 times 2 is 4. 2 is prime, 2 is prime. So that's completely factored. Okay, so I'm going to list the prime factorization of 12. It's 2 times 2 times 3. Okay, 24. Let's factor that. 3 times 8 is 24. 8 is not prime, so we've got to keep going. 2 times 4 is 8. 2 is prime. 4 is not, so let's keep going. 2 times 2 is 4. Okay, so now 24 is factored. Let's list the factors of 24. The prime factorization, excuse me. We've got 2 times 2 times 2 times 3. Okay, now what I want to do is I want to circle what each list has in common. Both of my lists have 2 2s, and both of my lists have a 3. Okay, both of my lists have 2 2s, and both of them have a 3. So to find the greatest common factor, I multiply what these two numbers have in common. So I multiply 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So the greatest common factor is 12. That's the answer I got when I made the list, right? This is just an easier way, generally a little quicker. Okay? Now let me show you one more way. I can also find the greatest common factor of two numbers using a method called upside down division. So let's take 12 and 24 again. And what I'm going to do is I'm going to put an upside down division box around 12 and 24. Okay, and I begin by thinking of something prime that goes into both. So I'm just going to use 2. Okay, 2 goes into 12 6 times. 2 divides into 24 12 times. Okay, now 6 and 12 are not prime, so we're going to keep going. Let's think of something prime that goes into both 6 and 12. We could use 2 again. 2 divides into 6 3 times. 2 divides into 12 6 times. Those are not prime numbers, both of them, so I got to keep going. Let's think of something prime that goes into 3 and 6. That'd be 3. 3 goes into 3 one time, and 3 goes into 6 twice. Now, look at the two numbers I have here, 1 and 2. The only thing that goes into both of those is 1. When I get to that point, when 1 is the only common factor left, I know I'm finished. Okay? Now, to find the greatest common factor, we multiply the prime numbers down the side. 2 times 2 is 4. 4 times 3 is 12. 12 times 12 is 1. So our greatest common factor, again, is 12. I get the same answer I did with the other two methods. So as we think about greatest common factor, what I want you all to do is I want you to practice. I want you to see what is the easiest method for you, okay? Again, I'm going to stress to you that lists is probably the most difficult method because the larger the numbers, the longer and longer your lists will be. When the numbers are large, my factor tree and my upside down division doesn't necessarily have to get any larger. So I would encourage you to think of one of those two methods as you do greatest common factor. I'm going to do both methods with this example. So I'm going to start with my factor trees for 36 and 45. Okay, what times what is 36? Let's do 4 times 9. 4 is not prime, so we got to keep going. 4 can be broken into 2 times 2. 9 can be broken into 3 times 3. Okay, so the prime factorization of 36 is 2 times 2 times 3 times 3. Now let's get a factor tree for 45 started. 5 times 9 is 45. 5 is prime, so we're done with that part of our tree. 9 can be broken into 3 times 3. 3 and 3 are prime, so I'm done there. So my prime factorization of 45 is 3 times 3 times 5. Now we circle the factors they have in common. Both of them have 2 3s. And that's all they have in common. So we multiply 3 times 3 to get 9. So the greatest common factor of 36 and 45 is 9. Now, let's do the same thing with upside down division, okay? We take 36 and 45 and we put them inside an upside down division. We have to find something prime that goes into both. And so I know I could use 3. 3 goes into 36 12 times. 3 goes into 45 15 times. 12 and 15 are not prime, so I got to keep going. 3 goes into both. 3 goes into 12 4 times. 3 goes into 15 5 times. The only thing I know of that goes into both 4 and 5 is 1. And remember, when I get to that point, I'm finished. Multiply down the side. 3 times 3 is 9. 9 times 1 is 9. So the greatest common factor of 36 and 45 is 9. Okay, now I want you to pick a method, and I want you to try finding the greatest common factor of 32 and 48. Just pause your notes. You can look back at your notes if you need to, but I want you to practice with 32 and 48. Let's see what we get here. Okay, so check your work. The greatest common factor should be 16. You can see my factor trees and see my upside down division. If you got a completely different answer, please feel free to come to class and let's talk about it. Let's look at your work together. Okay, let's do one final example. Let's make a factor tree for 7 and a factor tree for 19. 7, the only factors of 7 are 1 and 7. And when I think about 19, the only factors of 19 are 1 and 19. And so 7 is 1 times 7, and that's not a prime factorization because 1 isn't prime. So, and 19 has 1 and 19, and I can't list that as the prime factorization because 1 isn't prime. So in a case like this, when you go to factor two numbers, and the only thing they have in common is 1, okay, the only thing that goes into 7 that also goes into 19 is 1. If the greatest common factor of two numbers is 1, then we call those two numbers relatively prime, okay? Relatively prime is when the greatest common factor of two numbers is 1, okay? Relatively prime means the greatest common factors of two numbers is 1.